Hello, I'm Reid. I'm Professor of Soil Science at the University of East Anglia. My research here relates to soil properties and the services that soil provides for society. We're interested in landscape and how soil might regulate the flow of water, the storage of carbon and the provision of food. We're at the University of East Anglia today to look at soils across the parkland and the woodland and other parts of the campus. And we're going to use that opportunity to explore how soils feel, use our sense of touch to learn about soils and the properties of soil, and to think about how those properties relate to the services that soil provides.
I'm Louisa Moor. I'm a first year PhD student studying a project entitled Not All Soil Carbon is Equal. As we can see from the soil core we've just taken, there are differences as you move through the soil profile. So at the top we've got this topsoil layer which is a little bit darker and has more of a wet feel. As you move down the soil there's a subsoil layer here which is a lot more freely draining and stony and has a grittier feel. Here we have a woodland soil core. In the different horizons in the soil profile there are very distinct differences. So at the top we have this very organic matter rich dark humus layer where there's lots of leaf litter and the soil is protected from decomposition, and then as you move down through the soil it starts to get very sort of clumpy and the colour starts to change. At the bottom you can see there's lots more minerals in the soil as indicated by a sort of orange tint, and these indicate the different horizons in the soil, which are essentially the layers of soil that have different physical and chemical properties and may be indicated by the soil's colour, the soil's texture or its chemical composition.
We're in the woodland on the university campus and we've dug up our soil sample, and now we can get our hands in about this and start to explore and to feel the soil. And what we're discovering is it feels very gritty, it feels very sandy, and if we begin to manipulate the soil, we can test this texture by firstly seeing if we can form a ball, which we can, and then secondly if it will take any pressure, which as we can see it can, it crumbles. In contrast to our sandy sample, I've also brought a different sample, a very different material, a very clay-rich soil. So let's have a feel of this one. As we can see, it looks smooth, it feels slippery, it's much more squidgy and squishy compared to the sandy sample. And if we try and form a ball with this soil, it very easily takes the form of a ball, and it also will take some deformation as well. When we roll this sample out into a sausage, it's very easy to do this. And if we take a smaller section, we can likely roll this out into a longer, thinner thread. So here we have soil which looks different to the sandy sample, something that's much more manipulatable. And this tells us that it's a higher clay content. Again, this soil's starting to crack. It's not pure clay, it has some sand, a small amount, and some silt, which is why we're not able to completely roll this out into a long, thin thread.
I'm Jess Chapman. I'm a second year PhD student here at UEA. My project title is Soil Salvation, the Critical Decade for Soil Carbon. My research looks at the barriers and opportunities that Norfolk farmers face in transitioning to practices that help uplift carbon content in their soils, and that's under the banner of regenerative agriculture. So here we've got 25 grams of sand. This is pure sand, and this is sand mixed with organic matter, so it's 50% sand, 50% compost. And so we're going to be demonstrating the water infiltration capacity of each. Because this has a better pore structure, it allows the water to hold more than just pure sand, and this renders it more resilient against drought. So now we are going to pour 20 milliliters of water into each tube, starting off with the sand. And so as you can see, the water has infiltrated much quicker through the sand, and it's taken longer through the composted sand as the texture and the pore space has changed. And so if you add compost and organic matter to your allotments and to your gardens, it can help the water be much more available to your plants and help them grow better.
Here we have two plants which have grown in the two different soils that we've spoken about today. One plant has been grown in the clay soil, which is more nutrient rich and stores more water. And the other plant is grown in the sandy material, which is much more drought prone and has much lower nutrient loads. And you can see the plants have performed very differently due to the soil texture and the condition of the soil that they're growing in. So soils vary greatly. They vary across the landscape depending on the topography, and they vary with geography as well. This map of England and Wales shows the major soil types and how they're distributed across the landscape. Of course, if we look globally, soils vary even further, and the drivers of climate that prevail in different parts of the world or different parts of the United Kingdom to a large extent control the soil types that we see beneath our feet. So we've come down to the edge of the UEA Broad to have a look at a very different sort of soil. These sorts of soils we find around river margins, around lakes, on top of mountains, in our wetlands and in our valley floors. And this particular soil is called a peat soil. And it's important and special because it's packed full of carbon. And carbon is a super important element on the planet because it regulates our climate. So we'll be familiar with carbon dioxide in the atmosphere. Well, some of that carbon comes from emissions when land degrades and the carbon that's stored within the soil is released. And when we explore this soil with touch, we find a very different sort of material. It's very smooth, almost soap-like. It's like a black, soft, smooth soap. Quite different to the mineral soils that we've seen in other parts of the campus earlier today. By getting our hands in the soil, we discover so much. We learn about the soil's texture, and from this we can understand the basics of the soil's chemistry, its hydrology, how it stores water and regulates water flows, and how plants might grow in our soil.